The commercialization of computers changed the world of electronics.
I'd also like to have your Caesar salad.
If you wish to send a fax, transmit now.
They drive the information and communication era of today. Inside these machines, we find the integrated circuits which make commercial computers possible. Their evolution from vacuum tubes to transistors to the integration of components has led to the integrated circuits of today's computers and technological centers like Silicon Valley. It all begins with the growth of pure semiconductor crystals, usually made of silicon, an element found in the Earth's crust. Lightly doped silicon crystals are sliced into wafers, which are cleaned and polished on one side. On this polished silicon surface, many integrated circuits or chips are then fabricated. Each one of these chips is a complete circuit, consisting of many thousands of transistors and other electrical components. Each transistor acts like an on-off switch. With this transistor, positive charge to the gate attracts nearby electrons. An electron channel connects the source and drain, which allows current to flow, turning the transistor on. When the gate charge is removed, the transistor is off. This switching creates information as electrical pulses, which are read in the binary language of computers as zeros and ones. There are several major types of transistors. Some of these transistors are grouped to create tiny circuits called logic gates. These gates follow standard rules, known as truth tables, to perform specific functions. The inverter or NOT gate, for example, automatically changes the input to its opposite. These simple logic gates are the building blocks used to design integrated circuits. By properly combining simple logic gates, a designer can create complex functions to implement a vast array of useful operations. As semiconductor technology has developed, the number of components and the complexity of integrated circuits have drastically increased. Today's circuit designs require advanced computers and specialized software to help a designer complete a design without errors. The end product of the design process is the geometrical layout information, which controls where the transistors will be located and how they will be interconnected. These layouts are then fabricated on silicon by doping specific regions of the silicon surface through a series of repetitive steps, such as patterning, deposition, and etching. After the wafers have been fabricated, they move on to testing and packaging. In testing, the wafer slides beneath a probe card. Thin metal probes make contact with each pad on the circuitry, testing the flow of electrical current. A computer keeps track of which circuits have failed. In the inking machine, the failed circuits are marked with a black dot. Wafers are mounted on sticky mylar tape to keep them intact as the individual circuits are separated. An optical scanner aligns the wafer by checking specific points.